Welcome to this webinar on reinforced concrete plate design in FEM-Design. My name is Flavio Popescu. I am a support and sales engineer at Strusoft, Denmark. This is my email address and my telephone number. Please feel free to contact me. Today, my colleague Dennis will help me with questions. So please enter your questions in the question section in this window, and hopefully we can answer all of them during this webinar. So please type them in here. Okay, let's get started. I have a model here. I have a concrete plate supported by some walls and some columns. Now, I already made a calculation. It is a simple calculation, a simple analysis. Here in the calculate menu, under load combinations, I've just made a simple load combinations calculation. And I have some results. The first result you want to check is the deflection. So this deflection is important from the beginning. You find it in a new result, load combinations, displacements, and choose your load combination. Right now I have this serviceability load combination, and I'm looking at the deflection. So please be aware that you check this value before you go further with your design, as this is important from the beginning. If you get a good deformation of the structure, then you can proceed to the next steps. What we're going to do next is go to RC design. Here, I have different tabs for my surface reinforcement. I go to this surface reinforcement, and I have my design calculation parameters here. This is where I set up my calculation parameters. If I go to properties and right-click on my plate, I set here the diameter for my bar and cover. Now, these calculation parameters, they are used to set up this, this diameter of a bar and its cover. So I will be able to guess the position of the design force in the reinforcement. So I set that up here. I choose a quality, diameter, and cover for bottom and top. Here is also where I set an allowed crack width. Right now I set it to 0.3 for both bottom and top. Okay, I also have other options here. If possible, do not use compressed reinforcement and apply minimum reinforcement where it is relevant. I have the options to check these boxes or not. Okay. What I'm going to do next is perform a check on my plate. I just go to check and right-click. I will get this warning message that the reinforcement necessary for crack width calculation, there is no reinforcement at this given point, but I have not put any reinforcement yet, so that is fine. Now, I've made this check, and I get this big utilization here, which is not very useful for me, but I get these results here in the new result. So if I go to new result, I have these RC shell required reinforcement. So I get an idea of how much reinforcement I will need in my X and Y direction and for bottom and top. So I get an idea of how much reinforcement I should put in my construction. The next thing that I will going to do is go to Auto Design. Here in the Auto Design menu, I can set up my parameters, my design parameters. Just right click on my plate. And here I set up a base net. I set up the base net for the bottom face and for the top face. I choose the quality. I'm using Danish National Annex for my Eurocode right now. So the qualities is in Danish qualities. But you can set up your National Annex in the beginning or from settings, all calculation. I have to be in the structure tab. Settings, all calculation, code configuration. So you can choose here at any point your National Annex. Just leave it like this for now. So back to Auto Design. Auto Design parameters. As I was saying, I will define my base net with the diameter, spacing, and I will get an area for this type of bar. I'll do that for both my bottom and top, and I will allow some additional reinforcement. Now this additional reinforcement will be added by the program where there is need for it, where the reinforcement needs covering. Okay, I set up my parameters and I'm ready to design my plate. I go to the design function and I right click on my plate. And I can see that some reinforcement has been applied. If I go to check, I see here the utilization of my plate. I can see it here for the bottom reinforcement, X direction, bottom Y, top X, and top Y. What I notice here is that I have 102% utilization in my plate in the top layer in the Y direction. So I don't have enough reinforcement in that place. What I can do is go to result and I have missing reinforcement Y top. This is where the utilization is above 100%. And I can see here that it is somewhere around this, at the top of this column here in my plate. So I can see it's a small value. What is very, very special about FEM-Design is peak smoothing. So I want to go back to my finite elements tab. And I want to assign some peak smoothing. I can do this automatically in settings, all, calculation, mesh, and I have here auto peak smoothing region around column endpoints, and I mark that. I also have different options for my beams, for my walls and plates, line and surface supports. But for now, I want to put it at the column endpoints. So I click OK. And then I generate my mesh again. Now I have this peak smoothing here. applied on my plate. This peak smoothing function solves this singularity issue, which I will get. I will have infinite high values here, since I have a line connecting with a plate. So I will get a high force here. This peak smoothing will redistribute this force in the plate. So I will get less values and more realistic design values for my reinforcement. Now, I have this peak smoothing activated, and I want to recalculate and reevaluate my plate. So I go to calculation here, choose design calculations, and say check all structural elements. Now, to avoid the time, I am going to skip to a model where I have already peak smoothing, and the calculation is performed. So if I go to check my plate, I can see here that this issue was solved with the missing reinforcement. I now have a right amount of reinforcement and thus a good utilization, which is below 100%. What other thing I would like to show you here, as we see here the results in the utilization, there is this shear capacity. This shear capacity right now says not okay. This is a check for the shear in my plate. Now I can go to new result, check my reinforced concrete shell, and I have here shear capacity missing. This will give me an idea of where my shear capacity is needed. And I can see here that it is around this wall. Now, FEM-Design doesn't introduce shear reinforcement into the plate. This is something that you have to do on your own, but it is some shear reinforcement is needed here in the around the walls, and some stirrups can be added here. Also at the edge of my plate and here. But I can see the missing shear capacity on my plate. Now, I have a reinforcement in my plate. I have checked the utilization. I can also check new result, crack width. Let's say top. I see here I have some cracks with the dimension of 0.26 millimeters. Now this crack takes into account the stiffness of the concrete. So right now I have a crack width of 0.26 millimeters in my plate. And I also want to have a look load combinations, displacements. I can see that I have a 3.89 millimeters displacement. What I have the option to do is have a cracked section analysis. I go to Analysis, Calculate, Load Combinations, Set up by Load Combinations, and I can set a crack section analysis for my serviceability combination. Now, I have to make sure that this serviceability combination is quasi-permanent, so SQ. And I can perform a cracked section analysis. This cracked section analysis takes into account the reinforcement in the plate and the cracks. It decreases the stiffness in the cracked nodes. So it decreases the E modulus for my concrete. No, I'm sorry, I take that back. I just want to say that it takes the reinforcement in the plate and the cracks, and it decreases the stiffness in the cracked nodes. Yes, and I already have made a crack section analysis. I'm not going to do that, so we don't have to spend time on calculation. I will just show you a comparison. So let's see, I have my simple calculation here. And I have a crack section analysis here. So I've done the crack section analysis like I've showed before in this model here. What I notice first is a larger displacement. I have now 4.24 millimeters compared to 3.89. So I have a larger displacement with taking into account cracks. I want to take a look at the cracked width. So I also notice that I have smaller cracks. If I look at my other model, I will see, no, not here. I have to be in RC Design. New result, crack width top. I notice that I have smaller crack widths. This is due to the iteration process of the crack section analysis. Once a crack appears, the stiffness is decreased in the plate and the uncracked part of the concrete takes the loads, and so on and so on. So the more I get cracks, the lesser the stiffness becomes, and the surrounding uncracked concrete will take my loads. So I have these crack widths for my structure with crack section analysis and without. Let's see how we're doing with the questions so far. Good. Yes, everyone can hear me. Please remember to enter your questions here in the questions field, and we will do our best to answer them all. My colleague Dennis is going to help me with questions. Okay. Yes. I will continue. What I want to show you is the creep value. So I have reinforcement in my plate, and I want to see long-term deflections into my plate. So I go to Structure, and I go to Plate, Properties, and I right-click on my plate. I go to the material, and I can see here the field for creep. Here I can enter the creep value for my serviceability combination. Now, this will come in useful to have a creep calculator. This is something that FEM-Design provides. It is an online app. So it is called concretecreep.strusoft.com. And here you can enter your parameters for your material. Age of concrete, and time from casting to present day, age of concrete when loading started, the concrete characteristic strength, the cement type, relative humidity, cross-section of concrete section, and perimeter of the X section that is exposed to the surrounding environment. And I click calculate, and I will get a creep coefficient here. So I can use this to insert a creep value here. Let's say put 1.5. I can also enter a shrinkage value. This is something that I will put as 0.5 in this case, and click OK. What I need to do for the shrinkage is define a load case. So I go to load cases and I define shrinkage and choose plus shrinkage as the load case type. I click OK. And I have to remember to insert it in my load combinations as well. Like that. So make sure that I include it in my load combinations when I make the calculation. Now, I've prepared a analysis already, so we don't have to make the calculation ourselves. As I can see here, my structure, I have a creep of 1.6 in my serviceability and 0.5 in shrinkage. And if I take a look at my displacement, I can see now the displacement taking into account creep and shrinkage. So this is my process of designing a reinforced concrete plate. I have inserted reinforcement. I've made my checks. I've made my deflection checks as well for long term. Now I'm ready to set up a report. This is very easy to do in documentation module. And to make it very easy for me, I can set up a template. I go to templates, apply, and I have already made templates in my FEM-Design program. You can also make your own and customize your own. I am going to use this concrete plate template. I can see here that I have all of my results and all of my views for my reinforcement, my correct section, internal forces, and I can also edit my views, of course. If I click on this view, I have the option to go to new result, show internal forces, MY, let's say. Choose ultimate. So I can easily edit my results here, but this template allows me to have the views already and all of my documentation and reports inserted. This I can save as a Word document and enter a path. And save it as a Word document. Yep. I now have made a reinforced concrete plate design with FEM-Design. I want to take a look at the questions, and to make Dennis's life more easy, I'm going to give him, okay, he's okay. He's okay with typing the answers for the questions. So we're just going to keep this going until questions are answered. Yes, I think we have all the questions and answers. Yes, I want to show punching. There's also the option for punching reinforcement design. Let's minimize this. So in my reinforced concrete design tab, I have the option to do bar reinforcement, surface reinforcement, and punching reinforcement. Let's edit this scale a little bit down. Now, if I select punching reinforcement, I can set my design calculation parameters. I can select all of my punching zones. And here I can select the position of the column. If it's in the middle of the plate or an edge column or a corner column. I can do this for every column one by one, of course. I can also let it calculate it automatically, or I can choose it myself with a predefined beta value. I can also edit that value myself. For now, I'll leave it like that. And I will perform a check. I have here a list of all of my punching zones. Select all and perform a check. Looks fine. If I go to Auto Design, I can set my parameters. So I have three options for my reinforcement, for my punching reinforcement arrangement. I can have these bended bars, circular stirrups, or open stirrups. So I can choose for every one of them what reinforcement I need to put, what type of reinforcement, what type of punching reinforcement. So let's select this one. Right now there is no need for punching reinforcement, but I can increase the loads, I guess. Let's put 5. Okay, so I need some punching here. I go to Auto Design and I can design it with my parameters, and I can see that some reinforcement has been added. Is it also okay? No. I need some circular. Yep, this is fine. I can see my results. I go to new result. I have reinforced concrete punching utilization, and I can see a detailed result for my column. I can see here the arrangement of my reinforcement and the stirrups and the checks that it performs. And of course, I can add this to my documentation and have it ready for the report. So this is punching check for reinforced concrete plate. Okay. I think that was all. I can see that there are no more unanswered questions. Please feel free to drop me an email if you have further questions or further questions come up. Please visit our website. There's also a new website coming up soon. But right now, truesoft.com. And apply for a trial. If you go to products, FEM-Design, get a free trial version if you are not already using FEM-Design. Some of you are already users, so please, if you don't have it yet, you can get a trial here and test it for yourself. We'll also have support, and I can help you with any questions that you have. I think I will end it here. Thank you very much for attending, and have a good day.